All right, students, so I'm going to make a quick video on the monotonicity criterion, not to be confused with monotonous, but it helps me pronounce monotonicity. It actually has nothing to do with monotonous, but what does monotonicity mean? So, monotonicity criterion, if voters change their votes to increase the preference for a candidate, it should not harm that candidate's chance of winning. This can be an issue using the voting method of instant runoff, which we just learned. So let's take a look. And by the way, here's the key. It's the increase in the preference for a candidate. So if you increase some preference for a candidate, it shouldn't harm the chances of that candidate winning. So let's look at an example. What I'd like you to do is first test your skills on instant runoff voting method and see if you can figure out who wins this election using instant runoff voting. So who does win? So let's take a look. A has 74 votes. B has 48 plus 24, which is 72 votes. And C has 54 votes. So that's all of the choices for first place. So how instant runoff voting works, and there were a total of 200 votes. How instant runoff voting works is you eliminate whoever's in last, and you keep and allocate those votes to their next preference, and you keep doing that until somebody has a majority of the votes. So we're going to eliminate C, and then these C first place votes here go to A. So now A has 128 votes, and conveniently this is 200 votes, so I know 128 out of 200 is, well, what's half of 128? Because I want to get it to percent per 100. Half of 128 is 64, so that's 64%. All right, well, A wins that one. Let's take a look at another example. Let's say 19 voters for B switch to A. I know this is really not allowed in most elections where you can't go in and switch your vote. Maybe they were miscounted. I don't know. Anyway, let's say 19 voters change their mind and they switch from B to A. They want to increase their amount of votes for A, right? So A goes from 74 to 93 because these 19 voters switched. So that means that 48 plus 5 voters are going to B, and 54 voters are still at C. So A currently only has 46.5%. So who's in last? Well, in this case, B is in last. So we need to delete all of the B's. So we did that, and now look. These 48 votes are getting allocated to C, and these 5 votes are getting allocated to A. So the 53 votes are being subtracted from B, 5 of them go to A, and 48 of them go to C. Now C is the winner. So C has 51% of the vote, so C wins. So this is clearly an example of how monotonicity is violated. So hopefully this helps. And we're just going to bring up the funny cartoon again. Hope this helps, and please let me know if you have any questions. Thanks for watching.